Hi, this is Lab 6 from my Digital Logic Lab. In this lab I created a stack calculator similar to the calculators that Texas Instruments used to make a long time ago. Using this FPGA board here, let me explain real quick how a stack calculator works. So there's two different modules here. We have the stack calculator and a memory module. And the stack calculator will send an address for the memory to index into, and then upon a read it will put the memory data on the data bus and into the stack calculator. On a write, you'll also send it an address, but going through a tri-state buffer it will then be written into memory on a clock cycle. So this calculator has a couple different modes here depending on what switch 14 and 15 are. So right now they're at 0, 0. So if it's 0, 0, we could either pop or push onto the stack. If you flip switch 14, you can have the option of add or subtract, depending if you press the left button or the right button, which are right here, left and right. And then you could either clear the stack or send the pointer to the top of the stack. And you could also decrement or increment and look at the values on the stack. So I'm going to do a run through with a visual example here. I'm going to show you, this is what the stack looks like once you press reset on this board. So I'm going to come over here, I'm going to reset. I need to push this up here. Oh, actually, yeah. Okay, so let me reset. Okay, it's been resetted. This yellow light indicates that nothing is on the stack and that I'm currently in this state right here, where the stack pointer points to the first available address on top of the stack, and there's nothing inside memory here. And then I have this other pointer which tells me what I'm currently displaying on these 7 LEDs right here. Right now I'm at this address right here after resetting, and I have a value of 0 saved in memory at 0 address, so none of these LEDs are on, and this LED indicates that it is in fact empty. First thing I'm going to do is push the value 92 into the first empty area and then increment the stack pointer. So to do that, I'm going to push the value 92. In binary it is this value, so I'm going to match these switches here with that. So 0, 1, 0, 0, 1, 0, 0, 1. And then I have to put it in push mode, which according to this is both switches down. Okay, both switches here are down, and I hit the right button. It should push the value 92, and it does. And these LEDs indicate what value I'm currently showing at which memory address. So this is at 1111, 1111. So here we go. That's 127, the address. At address 127, the value 92 is stored, which is similar to this drawing here. And let's say I want to push a second value. I'm going to push the value 25. Let me flip the switches back. So binary, it's going to be 1, 0, 1, 0, 0, 1, 0, 0. I'm going to push that value. And 25 has been pushed on the stack. And the address is now 126, which is right here, 126, display value 25. One of the features of this calculator is you could cycle through and see what's all on the stack. You could do that by decrementing or incrementing that pointer. So I have to set both the switches high to do that. Then I could toggle through. So there at address 127 I have 92 still, just like that picture says, at 127. And if I go back down at 126, I'm at 25. Let's bring it back down to address 0. Address 0 I had 0, so everything is correct. Now I'm going to do the add function. Once I add 92 and 25 in hexadecimal, it should come up with the value B7 and push that value back onto the stack. So first it'll pop this value off and pop this value off, add them, and then put them back at this address. So to put it in add mode, I need to do 0, 1 there, and then I have to hit the right button. So once I hit right, it should push B7 on. Here we go, B7 at this address. Let's see if that matches this. Yep, B7. So and if I want, I could pop off the stack, which means that I'll have an empty stack and it should turn on that empty flag again. So how do I pop? I go down to 0, 0 and I hit button left. There we go, empty flag. And at address 0, I have 0. And that's my stack calculator. Thank you.